Hello students, this is your Professor Lázaro Pino, and now we are studying the electronegativity, types of bonds, the intermolecular forces. Let's begin by explaining what is electronegativity. Electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. The Pauling scale is the most commonly used. In this, fluorine is the most electronegative element and is assigned a value of 4.0. A value range down to cesium and francium, which are the least electronegative at 0.7. As you can see, fluorine is to the right and up, while cesium, that is the least electronegative, is to the right and down. That's the tendency in the periodic table of this property. If we make the difference of electronegativity between two atoms in a bond, we can observe that if the value is 4 or lower, we say that the molecule or the bond, is pure or non-polar covalent. And if the difference of electronegativity between the two atoms is between 0.4 and 2, we say that the bond is polar covalent, and if it is higher than 2, then we say that is ionic. And in this case, there is an electron transfer from the less electronegative to the most electronegative, and we get what? Ions. In these cases, in the case of polar covalent bond, we have one part of the molecule that is less electronegative, then more positive, and the other part more negative, but we don't have ions because the bond is covalent and the electrons are shared. Let's analyze some molecules, and then according with the shape we can say if the whole molecule is polar or not, but beginning from the analysis of the electronegativity difference between the atoms in a bond. For example, in water we have oxygen and two hydrogens. Even though the bond between oxygen and hydrogen is polar, we have to analyze the shape of the molecule. Since the molecule is bent, we can observe that these dipoles are not cancelled up, and that's why to the part of oxygen we find more electrons concentration than to the part of the hydrogen. Then this molecule is polar because of the shape of the molecule. If we analyze carbon dioxide in the bottom, the bond between oxygen and carbon is polar, but since the molecule is linear, these two bonds, these two dipoles are equal, but in the same line in opposite directions. They cancel up, and the whole molecule is non-polar. In the case of carbon with 4 hydrogen, every bond is polar, is non-polar, and the whole molecule is also non-polar. In the case of carbon dioxide, as we said before, the dipoles are in the same line and they are in opposite directions. Then they cancel up, and the whole molecule, or the net dipole moment, is 0. In the water molecule, as the water molecule is bent, the two dipoles cannot be cancelled out, and the net dipole moment is different from 0, so the molecule is polar. Let's see the intermolecular and intramolecular forces. The intermolecular forces are the forces between two molecules. They can go from weak to moderate, and we can find here dispersion intermolecular forces. They are very weak. The dipole-dipole interaction is when we have two molecules that are polar, and these interactions are from weak to moderate. The hydrogen bonds only happen when we have one atom of hydrogen and one of these three elements, fluorine, oxygen, or nitrogen, that are in this order the most electronegative atoms in the periodic table. Then, when we have hydrogen and one of these three atoms, we get hydrogen bonds between molecules, and it makes an extra attraction between two molecules that beside the ion and dipole molecules are moderate. If we analyze the intramolecular forces, it means forces inside the molecule or within the molecule, we can say that they can be from strong to very strong when we have ion-ion interaction. That's what happened in ionic bonds. And from strong to very strong, but not so strong as in the ionic compounds, are the covalent bonds. Then, first we have to analyze the difference of electronegativity between two atoms. In the case of nitrogen, nitrogen is 3.0 minus 3.0, that is 0. Then we say that this bond is non-polar covalent. Between chlorine and bromine, the difference of electronegativity is 0.2, is lower than 0.4, then is non-polar covalent. And the same thing between hydrogen and silicon, that is 0.3, and then is non-polar covalent. Here you have an exercise that you can do alone. You can stop the video and then you can answer this using the table that we provided at the beginning of this video. Well, that's all for today, and we will continue in other video.